Hello and welcome to another CN-Series snippet. My name is Spencer Tellman and I'm a Container Security Product Manager here at Palo Alto Networks. Today we'll be covering an introduction to Kubernetes constructs. So Kubernetes is a technology which was designed to simplify the management, orchestration, and deployment of containerized applications in a clustered environment. In Snippet 2, we put forth this image, which is a graphical representation of a Kubernetes cluster. The purpose of this snippet is to take a closer look at the different components of this cluster, in addition to the ways in which CN-Series can be deployed on any Kubernetes cluster. While Kubernetes creates challenges for traditional security tools, it also presents opportunities to enhance security by taking advantage of native constructs, most notably namespaces. Namespaces are virtual clusters running within physical Kubernetes clusters. Kubernetes namespaces help to simplify cluster management by making it easier to apply certain policies to some part of the cluster without affecting others. However, they are also a valuable security tool. Security teams use namespaces to isolate workloads to reduce the risk of attacks spreading within a cluster and to establish resource quotas to mitigate the damage that can be caused by a successful cluster breach. Forward-looking security architects want the ability to secure traffic that crosses namespace boundaries or travels outbound to legacy workloads such as bare metal servers. However, doing so requires knowing the internal state of objects such as namespaces, pods, and containers. Because that information is not available outside of the environment, the only effective solution is to take the security solution inside the Kubernetes walls, which is exactly what we've done with CN-Series. Moving on to pods and nodes. Kubernetes organizes containers into pods, which are the basic unit for scheduling. In Kubernetes, applications or namespaces run on pods, which are a collection of containers. Pods run on nodes, which are either physical or virtual machines. A cluster is a collection of nodes running on the same host. Clusters provide a mechanism for ensuring high availability. Developers rarely have to deal with nodes explicitly, but nodes impact how firewalls operate. Because of network address translation, or NATing, all outgoing traffic carries the node IP address as the source. The pod IP address are externally unavailable. As a result, firewalls sitting outside of the Kubernetes cluster are blind to the actual source of the traffic. In Snippet 3, we covered the deployment modes for CN-Series. In distributed mode, the firewall data plane, CN-NGFW, runs as a daemon set on each node. Daemon set is a Kubernetes construct that enables developers to spin up specific pods on every node. In our case, that's the data plane pod. In cluster deployment mode, the firewall data plane, CN-NGFW, runs as a Kubernetes service on dedicated security nodes. Cluster deployments are best suited for large Kubernetes environments where a distributed deployment would be resource intensive and cost prohibitive. Kubernetes services enable developers to expose applications, again in our case, CN-Series data planes, running on a set of pods as a network service. If you'd like to learn more about this, I would encourage you to take a look at these two resources. Firstly, our ebook, and secondly, the next snippet in which we will be covering what's new in CN-Series, 5G security. On behalf of the CN-Series product management team, I'd like to thank you for attending this session today. And I look forward to sharing more details on the CN-Series containerized next generation firewall with you in future snippets. If you're interested in learning more, please take a look at the description where we've provided helpful links to all things CN-Series. Thank you.